welcome to Moth+Flame's Ready Boss. Adam, what's BOSS stand for?
BOSS stands for Battlefield Operations Scenario Simulator.
Nice. And that's what we're in. It's a multi-user environment where we can view flight data and real terrain data all at once. How does this multiplayer work, Carl?
Yeah, so we're using Normcore as our multiplayer framework, and that allows us to sync our VR avatars. And you'll also notice that we're able to hear each other in real time with voice too.
Cool. We're also using some fancy interaction framework that lets us move around. What's that?
Yeah, so that's VRIF, VR Interaction Framework. Comes with a host of interactable components to include teleporting and grabbing and gripping objects as well. That's an asset.
Cool. Hey, this is a really cool table you've got here, Adam. What's going on with it?
Yeah, so we're reading Mapbox data and terrain data. We're displaying that on 3D mesh tiles to include the terrain. If you look at the mountains closely, you can see that. So we have the entire island of Oahu. We can load basically infinite terrain, and we use a kind of an infinite scroll strategy to where if you move past a certain amount of terrain, those tiles fall off and new tiles show up as you need them.
Cool. I also see like a tiny airplane here. What's going on with this tiny airplane here?
Yeah, there's a few planes. We have flight data that's literally being imported from DCS, which is a simulation framework that a lot of people fly like dogfighting missions or other combat missions in. We import that data and then we bring it into Unity and we can show it to you in full 3D space in real time for multiple objects.
So with that flight data, we're actually importing it in a fancy way that would allow us not just to use the flight of the single aircraft that came in, but would allow us to change the aircraft type that we're flying, or even to alter the mission even after it's been recorded. And I'll get into a little bit more detail on that later. Carl, you worked on this timeline scrubber, but Adam's in control of the video. So Adam, can you show us what's going on with this timeline thing?
Yeah, so Carl made this really awesome timeline scrubber. It works exactly like you would expect a video playback to work, but this time it's actual 3D objects in actual 3D space. So if we hit play, you'll notice the planes start moving around. Now, the planes here are obviously a little bit bigger than in real life because, for visibility's sake, we can see them over the entire island of Oahu. But if you wanted to jump to a specific part of the flight data to get, a very specific interaction, like whenever this missile hits or something, you can scrub to exactly when that takes place, much like you would a video player, and then you can jump into the action from here into the aircraft itself.
Flight data can come in from various sources. Here we have some ACMI data coming out of a simulator, but we also have integrations with Mace, Armor, and JSE. This flight data is coming in as ACMI data. This is giving us throttle position and positions of all our control surfaces multiple times per second. We translate that data into waypoints. This is about 20 minutes of flight in a flight simulator. These waypoints are used to fly an AI aircraft. The interesting thing here is we can have each of our AI aircraft have different flight parameters. So we can edit the maximum thrust, lift, and different characteristics. So we're not stuck with the aircraft that was flown for the flight, but we can have an arbitrary aircraft fly our flight path to generate our animations later on. So here I've given each of these aircraft different flight characteristics. This top one, number 1, has very high thrust. Number 5 is very low thrust, very low lift. And you can see it's struggling to get to the waypoints. So let's have a look at how they progress through the flight. Number one, because it is moving so fast, it was overcompensating for hitting some of the waypoints. The others are even struggling to get to the altitude for that. So this gives us lots of flexibility. Also, because we're working with the waypoints and not specific location data, we can now grab those waypoints and change the flight path that they have to go through. In some cases, we'd like to record our own flight data with an arbitrary aircraft configuration and fly against other aircraft that have been previously recorded. So I have against our stick control for this aircraft, and I'm flying against real flight data that was already previously recorded. So this is AI flights that were flown following real flight data and saved, and now I can fly against them here. Not all of our flight data is pre-recorded. We can get flight data from live API requests. Here we've integrated with OpenSky to get all the flights that are currently on Earth right now. So here's all of the flights that are currently active in the United States and actually globally. We can use this data to pipe in and show any flight in real time as it's happening globally.
All right, so here we are back at the command center. We have our map of Oahu out here. We have our flight data with aircraft represented on the map. These aircraft are obviously a lot larger than they would be in real life, but that gives us good visibility on the battlefield for now. So the cool thing about this is we have a timeline where we can scrub through an entire mission, find a point we want to play that mission back in real time, and see all the jets interacting together all at the same time. If there's a specific time frame you want to check out closer, go to where the interaction happens. All right, let's check that out. Let's fly over the Honolulu airport with this jet. So we'll play it from there. We'll teleport on this jet. Notice my cursor locks into play. Let's teleport. All right, so here we are in my jet. I'm flying over the bay. You notice I'm a little low, but you can see. We're in a full high fidelity cockpit that we use for our Ready VR training. This cockpit normally has all working gauges, all working switches to include throttle, yoke, all of the dials and gauges and everything. Notice it just teleported out. We'll jump right back in. All of those gauges work totally fine. You can see that we can see like street markings. We have live terrain data out on the mountain range. There's the airport to my left, and we're back on the ocean. You would also be able to see aircraft in this instance, but they are real scale. There's one down to my port side here. Now it's to my starboard. It's right out there if you can see it. It's kind of hard to track, but there are aircraft out there that you can see and track. So this is our interior. And then, like I said, you can just hit a button and go right back to the command center. Boom, there we go. So now we're back to the command center. Mission's still playing out. We can go view that from another angle or jump right back into another aircraft. The cool thing about this is it can load mission data from other applications such as TacView, Mace, or any other battle simulation data. Even simulation frameworks like DCS, for instance. Yeah, so that's our BOSS, Battlefield Operations Scenario Simulator, teleport feature. Thank you.
Welcome to Moth+Flame's Ready BOSS. In light of our secret ingredient, BOSS now stands for Battlefield Operations Space Station. For that, I'm wearing appropriate attire, spacesuit helmet. Our theme is 2001: A Space Odyssey. You can see we have our spacesuit station, our HAL 9000 diagnostic unit, and we can observe space operations from here. You can see docking of the Orion 3 spacecraft with Space Station 5 outside our window and in full scale. We can watch the departure of the Discovery spacecraft on its flight to Jupiter. Outside our windows here, we can observe the ISS as well as the real Discovery spacecraft. And our Earth, we can see all of the flights that are happening live right now throughout the globe. Besides this static changes, we can still scrub through all of our flight data that has been pre-recorded and jump into our flights in full scale as always. But for now, I'm more interested in taking a ride in the space pod. Thanks for watching.